Have you ever looked up at the night sky and wondered what's out there? We see stars, planets, galaxies. But what if the vast majority of the universe is completely invisible to us? What if we're swimming through an unseen river of cosmic material right now, without even knowing it? This isn't science fiction. This is the reality of dark matter, one of the biggest mysteries in modern science. And just this year, in 2024, a group of physicists propose a groundbreaking new way to finally see it. Not by looking at distant galaxies, but by looking right here at our own planet Earth. For nearly a century, scientists have known something was missing. When they looked at galaxies, they saw them spinning so fast. But according to the laws of physics, they should have flown apart. The stars on the outer edges were moving just as quickly as the stars near the center. The only way this makes sense is if there's a huge amount of extra mass, a kind of gravitational glue, holding everything together. But this mass doesn't shine. It doesn't reflect light. It doesn't interact with anything we can see. Take Kayadit, dark matter. Think of it like this. Imagine you see a carousel spinning. You can see the horses. You can see the lights. But what you don't see is the massive engine and support structure underneath that makes it all work. Dark matter is like that invisible engine for the entire universe. It bends the light from distant galaxies. It shapes the large-scale structure of the cosmos, but the matter itself remains a ghost. It makes up a staggering 85% of all matter in the universe. Everything we've ever observed, every star, every planet, every person, is just a tiny fraction of what's really out there. So, the billion-dollar question has always been, how do we detect this stuff? Scientists have built incredibly sensitive detectors deep underground, shielded from all other cosmic radiation, hoping to catch a rare, fleeting glimpse of a dark-mattered particle bouncing off a nucleus. They've smashed particles together at unimaginable speeds in colliders, hoping to create a dark matter particle in the resulting explosion. So far, after decades of searching, nothing. The ghost remains elusive. This is where the new 2024 proposal comes in, and it completely flips the script. Instead of building a bigger, more sensitive box to catch a single particle, what if we used the entire Earth as a giant dark matter detector? The idea is based on something called dark matter streams. Our solar system isn't just sitting still, it's orbiting the center of the Milky Way galaxy at a blistering 230 kilometers per second. As with Otis, we're constantly plowing through the vast, invisible halo of dark matter that surrounds our galaxy. Now, most models assume this halo is a smooth, uniform cloud. But what if it's not? What if it's clumpy and filamentary, like streams or rivers of dark matter flowing through space? If that's the case, then as the Earth orbits the Sun, and the Sun orbits the galaxy, we would periodically pass through these denser streams. It would be like sailing on a calm sea and suddenly hitting a strong, invisible current. So, how would we notice this? The theory suggests that as the Earth passes through a dense, dark matter stream, the particles in that stream would interact with the particles in our own planet. Not a lot, but just enough to cause a tiny, almost imperceptible effect. The key insight is that this interaction wouldn't be random, it would be directional. The stream is coming from a specific direction in space, so we should see a signal that changes depending on Earth's position in its orbit and the time of day. Think of it as a dark matter wind. When the part of the Earth you're on is facing into this wind, the effect should be stronger. When it's on the opposite side, shielded by the rest of the planet, the effect should be weaker. This creates a daily or diurnal pattern. Furthermore, as the Earth orbits the Sun, the angle at which we hit this stream would change throughout the year, creating an annual modulation. It's this unique, repeating pattern, the specific when and where. That could be the smoking gun. But what signal are we even looking for? This is the most brilliant part of the proposal. The physicists suggest we don't need a new experiment at all. We just need to look at existing data in a new way. Specifically, data from the global network of magnetometers and GPS stations. These are instruments that constantly monitor the Earth's magnetic field and our precise position in space. The theory goes like this. If a stream of certain types of dark matter particles, like hypothetical particles called axions, passes through Earth, it could interact with the Earth's magnetic field. This interaction would create a tiny, oscillating disturbance in the magnetic field, a signal that our global network of magnetometers might be able to pick up. The signal would be incredibly faint, buried under all the noise from solar storms and other terrestrial activity. But because it would have that very specific daily and annual pattern tied to the direction of the dark matter stream, we could use sophisticated data analysis techniques to pull it out of the noise. It's like trying to hear a single, specific note being played very quietly in the middle of a roaring stadium. It's impossible to hear directly, but if you know the exact frequency of the note you're listening for, you can use a computer to filter out everything else and see if it's there. The physicists have essentially given us the sheet music for the song dark matter might be playing. This new approach is revolutionary because it repurposes our entire planet and its technological infrastructure as a scientific instrument. We have decades of high-quality magnetometer and GPS data just sitting in archives. The evidence for one of the universe's greatest mysteries might not be in the results of a future multi-billion-dollar experiment, but hidden in plain sight in data we've already collected. Of course, this is still a proposal. The real work is happening right now. As scientists around the world begin the painstaking process of sifting through these massive datasets, searching for that telltale pattern. It's a search for a cosmic needle in a planetary haystack. They have to carefully account for every other possible thing that could create a similar signal, from solar flares to subtle wobbles in the Earth's core. But the potential payoff is immense. If they find a TIFF, they find a signal that matches the predicted daily and annual modulation and points to a consistent direction. In space, it would be one of the most significant discoveries in the history of science. It would not only prove that dark matter exists, but it would tell us what it's made of and how it behaves. We would finally have a window into the 85% of the universe that has been dark to us for so long. This is science at its best. A creative, elegant idea that combines astronomy, particle physics, and geology. It reminds us that sometimes, to solve the biggest mysteries out there in the cosmos, we need to look very carefully at the ground beneath our feet. The invisible river of dark matter may have been flowing past us all along, and we might just be on the verge of finally learning how to feel its current. Thanks for joining me on this journey into the dark side of the universe. If you enjoyed this exploration of cosmic mysteries, don't forget to hit that like button. Subscribe for more adventures in science. Ring the bell so you never miss an update.